There are places in the universe where physics breaks down, where reality stops making sense, and where our most advanced theories hit a wall and collapse. These aren't science fiction locations. They're real places that exist right now. And what happens inside them is so incomprehensible that scientists can't even agree on whether asking what's inside is a meaningful question. In 2019, humanity photographed a black hole for the first time. The image showed a glowing ring surrounding absolute darkness. That darkness isn't empty space. It's a region where gravity is so intense that nothing, not light, not matter, not information itself, can escape. The boundary is called the event horizon. Cross it, and you're erased from the universe, not killed. Every piece of information about you lost forever. We photographed it. We just don't understand what it actually is. In 1998, astronomers discovered that the universe isn't just expanding, it's accelerating. Something is pushing galaxies apart faster and faster. Here's the problem. Dark energy makes up 68% of the entire universe, and we have absolutely no idea what it is. It's not matter. It's not radiation. It's not anything we can detect, measure, or understand. Two-thirds of reality is made of something we can't explain. That's not a mystery. That's a crisis in physics. Scientists detected gravitational waves from two black holes colliding 1.3 billion light-years away. The collision released more energy in a fraction of a second than all the stars in the observable universe combined. And we felt it, a ripple in space-time itself, stretching and squeezing space as it passed through Earth. The place where that collision happened is still there, still warping space-time, still doing things we can't fully model with our equations. Reality itself got damaged in that spot, and the damage is permanent. But here's what should terrify you about the universe. These aren't rare anomalies. These are fundamental features of reality. Black holes exist everywhere. There are probably 100 million in our galaxy alone. Dark energy is accelerating every cubic meter of space. Gravitational wave collisions happen constantly. The universe is full of places where our understanding completely fails, and we're only just beginning to discover them. This is the 5 most mysterious places in the universe. What makes each one incomprehensible to physics, and why every answer scientists find creates 10 more questions they can't solve. The event horizon of a black hole, where reality has an edge. Let me explain what makes a black hole's event horizon so fundamentally weird. It's not just really strong gravity. It's the place where space-time itself gets so warped that cause and effect stop working normally. Here's how normal space-time works. You're in a room. Light from a lamp travels to your eye. The past, light leaving the lamp, causes the future, you seeing it. Time flows forward. Space is three-dimensional. Cause comes before effect. This is reality, as you understand it. All of that breaks. Imagine falling toward a black hole. As you approach the event horizon, time slows down relative to the outside universe. Not metaphorically, literally. If someone watched you fall in, they'd see you move slower and slower, approaching the event horizon but never crossing it. Your last moment before crossing would be stretched across infinite time from their perspective. You'd appear frozen at the edge forever. You cross the event horizon instantly. No hesitation, no slowing. You just fall through. Both perspectives are equally valid according to relativity. You cross the boundary in finite time. Outside observers see you frozen there forever. These contradictory facts are both true simultaneously, and it gets worse. Once you're inside the event horizon, the center of the black hole isn't in space anymore. It's in your future. Not ahead of you in space, in your future. You can't avoid it any more than you can avoid next Tuesday. Moving away from it would require traveling backward in time. The singularity at the center isn't a place you could choose not to go. It's a moment you will inevitably experience, like death. But here's the part that breaks physics completely. At the singularity itself, density becomes infinite, space-time curvature becomes infinite, Our equations output infinity, which in mathematics means this model is broken. We don't know what happens at the singularity. General relativity, our best theory of gravity, throws up its hands and says, I can't compute this, and the information paradox makes it even worse. According to quantum mechanics, information can't be destroyed. Every particle that falls into a black hole contains information, its position, momentum, quantum state. But black holes erase everything. When the black hole eventually evaporates through Hawking radiation, does that information come back out? If yes, how? Theft quantum mechanics is wrong. Physicists have argued about this for 50 years. Nobody has a satisfying answer. The event horizon is a place where space-time has an edge. Cross it, and you leave the universe. Not physically. The universe is still there. But causally, nothing that happens to you inside can ever affect anything outside. You've been deleted from reality's story, and reality doesn't care. The cosmic void, 1 billion light-years of almost nothing, in 2007, astronomers discovered something that shouldn't exist. A region of space, 1 billion light-years across that contains almost no galaxies. It's called the Boötes Void, and it's one of several cosmic voids scattered throughout the universe. These aren't empty space between galaxies. Those are common. These are regions so empty that they violate our models of how structure formed in the universe. Here's why voids are bizarre. After the Big Bang, matter was distributed relatively evenly throughout space. Gravity pulled matter together into clumps that became galaxies. The clumps formed a cosmic web, a network of galaxy clusters connected by filaments, with voids in between. That's what we expected, and that's mostly what we see. But some voids are too big. There hasn't been enough time since the Big Bang for voids this large to form naturally. The Boötes Void is so large that light takes 1 billion years to cross it. For gravity to clear out that much space, it would need more time than the universe has existed. And yet, there it is. What's inside these voids? Almost nothing. A typical region of space this size contains tens of thousands of galaxies. The Boötes Void contains about 60. That's a 99.99% reduction in galaxy density. The few galaxies inside are moving strangely, like something pushed them to the edges and held them there. But here's what makes astronomers uncomfortable. When you look at the cosmic microwave background, the afterglow of the Big Bang, there's a cold spot that aligns with one of these voids. The cold spot is a region where the CMB is slightly cooler than surrounding areas. It shouldn't exist either, according to our models. And it lines up perfectly with a supervoid in that direction. One theory, and this is where it gets unsettling, is that these voids are being influenced by something from outside our universe. Collisions with parallel universes or quantum fluctuations from higher dimensions. This sounds like science fiction, but physicists seriously propose it because the alternative explanations require rewriting our understanding of cosmic structure formation. The voids are mysterious because they're defined by absence. There's nothing there to study. We can only measure what's missing and try to figure out why. It's like finding a giant hole in reality and not knowing what dug it. The Great Attractor. Something is pulling our galaxy, and we can't see it right now. Our entire galaxy is being pulled towards something at 1.4 million miles per hour. So is every other galaxy within 500 million light-years. We call it the Great Attractor. And we have no idea what it is because it's hidden behind the Milky Way itself. Here's what we know. In the 1970s, astronomers noticed that galaxies in our region of space are all moving in the same direction toward a point in the constellation Centaurus. This isn't random drift. It's coordinated motion, like water flowing toward a drain. Something with enormous mass is pulling everything toward it. The calculations suggest an object with the mass of tens of thousands of galaxies concentrated in a relatively small region of space. For comparison, our entire local group of galaxies, including the Milky Way, Andromeda, and 50-plus dwarf galaxies is being dragged toward this thing like leaves in a current. But here's the problem. We can't see it. The Great Attractor is located behind the zone of avoidance, a region where the Milky Way's dust and stars block our view of distant space. Visible light can't penetrate. Radio telescopes can partially see through, but not clearly. We can measure its gravitational effect, but we can't directly observe what's causing it. And it gets weirder. In 1987, astronomers discovered something even larger pulling on the Great Attractor. They called it the Shapley Supercluster, a collection of 8,000 galaxies located 650 million light-years away. But then they found evidence of something even more massive beyond that, called the dipole repeller, which is pushing from the opposite direction. So our galaxy isn't just falling towards something, it's caught between multiple massive structures pushing and pulling us through space. The motion is so complex that we're still trying to map it. It's like discovering you're in a river, then realizing the river is inside an ocean, then finding out the ocean is draining into something even larger that you can't see yet. But here's what keeps astronomers up at night. These structures, the Great Attractor, the Shapley Supercluster, the dipole repeller, are larger than our models predict should exist. According to our understanding of cosmic evolution, structures this massive shouldn't have had time to form since the Big Bang. And yet, they're there, pulling us. Invisible but undeniable, the Great Attractor is a place defined by force without form. We know it exists because it moves galaxies. We just don't know what it is, and we may never directly observe it. We're being pulled toward a mystery at 1.4 million miles per hour, and all we can do is measure our own acceleration. Sagittarius A, the monster at the center of our galaxy. There's a black hole at the center of the Milky Way that weighs 4 million times more than our Sun. It's called Sagittarius A*, pronounced A-star, and it's 26,000 light-years away in the constellation Sagittarius. Right now, as you read this, stars are orbiting this thing at 5,000 miles per second, 2.5% the speed of light. And occasionally, something falls in. Here's what makes Sindral a special. We've watched stars orbit it for 30 years. One star, called S2, completes an orbit every 16 years. At closest approach, Sagittarius A reaches 2.5% the speed of light and experiences gravitational forces that should tear it apart. But it survives, and by tracking its orbit, we've mapped the black hole's mass and position with incredible precision. But the mystery isn't the black hole itself, it's what happens near it. In 2020, astronomers observed something completely unexpected, a star called Ceph 4714 that passed within 15 light-hours of Sec. That's about 100 times the distance from Earth to the Sun. At closest approach, Ceph 4714 was moving at 8% the speed of light, the fastest star ever observed. How did Ceph 4714 survive? At that distance, tidal forces should have ripped it apart. The difference in gravity between the star's near side and far side should have been enough to shred it. But it's still there, still intact, still orbiting. Something about the star, its density, composition, or internal structure, allowed it to survive an encounter that should have been fatal. And then there are the flares. Every day, Sagittarius A* brightens suddenly in X-rays and infrared. These flares last hours and release energy equivalent to what our Sun produces in 100 years. Something is falling into the black hole during these flares. Gaze, debris, maybe entire asteroids. We're watching the black hole feed in real time. But here's what disturbs astrophysicists. Sagittarius A is quiet. Supermassive black holes at the centers of other galaxies are often incredibly active, consuming massive amounts of matter and shooting jets of energy millions of light-years into space. Our black hole is barely eating. It's like having a lion at the center of your house that only eats once a month. Why is it so dormant? What would happen if it woke up? If Scragga suddenly became active, if it started consuming matter at the rate other supermassive black holes do, the radiation would sterilize this side of the galaxy. Not immediately. The radiation would take 26,000 years to reach us, but it might already be happening. We wouldn't know for another 26,000 years. The apocalypse could already be in progress, traveling toward us at the speed of light, and we'd have no warning until it arrived. Sagittarius A is a sleeping monster at the heart of our galaxy. We live in its gravitational domain. Our solar system orbits it at 514,000 miles per hour, completing one orbit every 230 million years. We're circling a cosmic drain, and we don't know if it will stay asleep forever or wake up and consume everything within 50,000 light years. The observable universe's edge. A horizon we can never cross. The observable universe has a boundary, not a physical edge. There's nothing there to stop you. It's an information boundary. Light from beyond that boundary hasn't had time to reach us yet, so we can never see what's there, no matter how long we wait or how powerful our telescopes become. Here's the math. The universe is 13.8 billion years old. Light travels at 186,000 miles per second. You'd think we could see objects up to 13.8 billion light-years away. Right. Wrong. The universe has been expanding the entire time. Light was traveling toward us. By the time light from distant objects reaches us, those objects are now 46.5 billion light-years away. That's the radius of the observable universe. But here's the disturbing part. The universe beyond that boundary still exists. Stars, planets, maybe civilizations. We can never see them, not because they're too faint, because their light hasn't reached us yet and never will. The expansion of space is accelerating, meaning distant objects are moving away from us faster than light can travel toward us. Think about what that means. Right now, there are galaxies crossing the boundary of our observable universe. They're moving away so fast that their light, which was traveling toward us for billions of years, will never complete the journey. They're vanishing from our reality. In 100 billion years, almost every galaxy we can see now will have crossed this boundary and disappeared. Future astronomers will look up and see almost nothing, just the local group of galaxies bound together by gravity, surrounded by endless darkness. But it's worse than that. Because of cosmic acceleration, the observable universe is shrinking. The boundary of what we can see is moving inward. Every second, thousands of galaxies cross the horizon and disappear from our potential knowledge forever. The universe is erasing itself from our view, and there's nothing we can do to stop it, and we have no idea what's beyond the boundary. Stars, planets, extending infinitely. Maybe the universe is infinite, or maybe it's not. Maybe 100 billion light-years out, the universe ends, or loops back on itself, or connects to other universes. We can never know because we can never see beyond the information horizon. The edge of the observable universe is the ultimate mystery because it's permanently unsolvable. We can theorize, model, and speculate, measure, or confirm. It's a boundary not of space, but of knowledge itself. Beyond it lies reality that exists, but is forever beyond our reach. Here's the pattern you've probably noticed. Every mysterious place in the universe reveals the limits of human understanding. Not temporary limits that better instruments will overcome. Fundamental limits built into the structure of reality itself. Black hole event horizons separate reality into two domains that can never communicate. Physics breaks at the singularity, and information might disappear forever. Cosmic voids are too large to exist, yet they do. Something cleared out billion light-year regions of space using mechanisms we don't understand. The Great Attractor pulls our galaxy towards something we can't see. We're being accelerated through space by forces we can measure but not observe. Sagittarius A sits at our galaxy's center, dormant but potentially catastrophic. We orbit a black hole that could wake up and sterilize half the galaxy without warning. The observable universe has a boundary we can never cross. Reality extends beyond what we can ever know, and that boundary is shrinking. These aren't mysteries waiting to be solved. They're features of a universe that's fundamentally more strange than our brains evolved to comprehend. We're apes with telescopes, trying to understand phenomena that operate on scales from subatomic to cosmic, using physics that breaks at both extremes. These 5 places aren't special, they're just the ones we've discovered so far. The universe is 93 billion light-years across. We've explored 0.0000001% of it. Every time we build a better telescope or develop a new detection method, we find more places where physics fails and reality stops making sense. The universe isn't just stranger than we imagine. Haldane said, it's stranger than we can imagine. Dark energy, or the edge of observable reality, requires weather and social hierarchies. The fact that we can comprehend any of this is miraculous. The fact that we keep finding places that break our comprehension is humbling. These mysterious places exist right now. They're not theoretical. They're not science fiction. They're features of the universe you live in. And the more we discover, the more we realize how much we don't know, can't know, and may never know. The universe is full of places where reality itself becomes incomprehensible. We found 5. There are probably millions, and every single one is an invitation to feel small, confused, and absolutely fascinated by how mysterious existence actually is.